everyone, I'm Crystal Berry from IDERA, and I'd like to welcome you to this webinar entitled The Conceptual Data Model as a Cornerstone for Data Strategy with Steve Hoberman. Also joining us today is IDERA's Jamie Knowles, who will be sharing some information about the latest features of VR Studio with you all later on in the presentation. At this time, I'll turn things over to Steve so he can get started. Steve?
Great, thank you, Crystal, and welcome everybody. So I'm Steve Hoberman, and we're going to talk about today 5 different topics. The first will be around the importance of precision, and then we'll talk a little bit how precision helps us with our conceptual data model, which I call the business terms model, and I'll talk about why as well, keep you in suspense until just a few slides from now, and then cover the 3 important challenges we face with the conceptual data model, talk about how it connects with data strategy. It's interesting, the last few projects that I've worked on was all about not building a logical, not building a physical, but purely using the conceptual data model in combination with some data governance initiative or some program level data initiative. And we'll talk about how it connects to that. In addition, we'll show you how it fits in with the big picture, conceptual, logical, physical, and then we'll end with some important takeaways. We have here, actually, this is a picture of me this summer, a summer at the Jersey Shore. I don't know how many of you like to go to the Jersey Shore, but I go to a bagel place, and once a year they bring in something from the 80s, so I had a chance to actually ride the bike that was used in the E.T. movie. And actually, that's the real E.T. from that scene, which is kind of cool. So that's my claim to fame there. I was not in the movie E.T. I just had my daughters take the picture. So are you ready? Let's talk about precision first. So just like we create a blueprint to give us an understanding of an architectural landscape, we create data models to help us understand information landscapes. And what the blueprint and the data model have in common is that there's only a few symbols. If we know how to read the symbols, we can have some really important, intelligent conversations as to whether we got it right or not. Working on a blueprint, we could talk about the lines representing the borders of a room. If we're talking about a data model, we could talk about the lines representing business rules on a relational or navigation paths on a dimensional, for example. And once you and I speak the language, once we know what the 0 means, the 1 means, the many means, we can actually discuss the content. It's really, once we understand the syntax, we could discuss the semantics. And I teach a data modeling class. I've actually been teaching data modeling for over 30 years. And we do a number of exercises where I'll share a data model, and as soon as people know what the symbols mean, within seconds, they're challenging it. Why did you do it this way? I mean, what does this term mean? Why is there a 0? It should be a 1. And so that's how you get some really useful conversations going about how the business works. And it all comes down to precision. Precision means there's only one way to read anything on the model. So we publish books, and let's say somebody makes this statement: books can be ordered. That's not precise, because you might think you know what that means, and I might think I know what it means, but we may not really realize it means the same thing. And so we need to go through this journey of asking a lot of questions to make it precise. Okay, books could be ordered. What is a book? What is an order? Can a book appear in more than one order? Can an order contain more than one book? Can a book even exist if no one's ever ordered it? Can an order exist without any books? And a few other questions too. And once all these questions get answered, we create this precise model. It looks very simple, but there's a painful journey to get to this point where we have this diagram. And then once we have this diagram, there's only one way to read it. And so what we do is we build data models to confirm and document our understanding of other people's perspectives. Precision gives us this amazing communication tool because, well, I'll give you an example. A few years ago, I worked with a financial company, and they were building this massive human resources application. And they brought me in to provide an overview to data modeling to the senior managers in this company. And the last thing these senior managers want to do is sit in a room, and they picked an awful time. It was like 5 o'clock on a Friday, and we were in their skyscraper on the 60th floor. The last thing they want to do is hear somebody come in and talk about data modeling. So what I did is I gave them a quiz. I said, really, they all had a paper, pencil I gave out, and I gave them a number of questions to answer. And one of them was, what's an employee? And after a few minutes, I saw the writing had stopped, and I asked them to share their responses, and no two answers for what is an employee were the same. Isn't that amazing? Here's a company embarking on a tens of millions of dollars project to redo their human resources application, and they do not know what an employee is, which was really amazing. And they were amazed about that too, and they realized how important modeling is. Because when you're building an application, it's kind of like a game of telephone. You know, when we're kids and I whisper something in your ear and you whisper something to the person next to you, by the time it works its way around the room, the last person says out loud what they heard, and it sounds nothing like what I whispered in your ear, and everybody laughs and it's funny. That's really application development. I'm going to whisper a requirement in your ear, and by the time it works its way around the room, from the business sponsor, the business experts, the business users, the business analysts, the data architects, the data modelers, the technologists, the developers, the database administrators, the testers, the people who deploy, the people who train, and managers of all these people. By the time it works its way around the room, that last person says out loud what they heard. It sounds nothing like the requirement that I whispered in your ear. Even with iterative methodologies like Agile, the opportunity to take something ambiguous and not interpret it the right way is very, very high. And so what data modeling lets us do is it lets us carry our understanding of the requirements in a very precise diagram, very precise form, all the way around until the last person hears exactly what the first person said. And the initial part, when we're talking with those business experts, is where the business terms model comes in, where we have a set of symbols and text. And what our goals are for this? It's a precise minimal visual tool. The goals are to build something for a particular audience and a particular initiative. Those are the most important words here. Initiative meaning your project, your program. We're very much focused on what the scope is of what we're trying to accomplish with building an application, understanding some business area, understanding an existing application even. And then we're also very focused on a particular audience. Who is going to benefit from this model? And you find we use certain terms like customer, product, employee, and you customize these terms. If you work for an airline, customer may be a passenger. If you work for a hospital, customer may be a patient, for example. We stay away from the details like views and system fields like last update date and customer IDs, surrogate keys, and so on. Sometimes we face these kinds of issues where if you are building a dimensional business terms model, our main entity is actually a process. We're determining how well a process is doing. And so we could have a manufacturing process that we're looking at different levels of granularity. The data modeler often wrestles with abstraction. And sometimes terms like party, organization, person, thing, document, agreement, and so on are very generic and hard for people to understand. So we need to determine, okay, if we use something really generic, like a party entity, will the audience get it? Will they really understand what it means? And a lot of times the answer is no. And so we need to really think of other terms that really mean something to our audience. M2M stands for many-to-many. We easily could have many-to-many relationships between our terms. We don't have to follow the rules of relational theory and resolve many-to-manys. It's okay to have a many-to-many. And phone number, we don't distinguish really what's an attribute, what's an entity at this stage. We're just focused on the most important terms. If you work for a phone company, for example, maybe phone number is a term that we would have on our model. I know that because I worked for a phone company. I worked for Bell Labs for a number of years, and phone number was a conceptual entity, really important term on our model. When I worked for a candy company, it was just any other attribute, a contact, an employee phone number, a customer phone number, and so on. I start every project with a business terms model, and the reason is it actually helps us define our scope. I worked with a university a number of years ago. They were working on this massive project, and they did not know where to begin. So I worked with them, and together we built a business terms model of their whole university, and it became a wonderful scoping tool. It was their roadmap. Also, when you're looking at the world at a high level, you expose big issues very early. Even with working with this university group, we came across the term student. Okay, you would think a university would know what a student is, but this university had so many different definitions for student. And since then, I've consulted with other universities, and nobody really knows what a student is anyway. Well, why is that? Well, student's a customer, and who really knows their customer anyway? But it was amazing to see this really valuable conversation as to what a student is by looking at the world at this high level. If we just jump right to a design, I might ask a question like, well, what do you want to know about the student? Well, I want to know their first name, their last name, their birth date. We never would have such a rich conversation. What is a student? And if we resolve that to come up with a really good definition for student, those definitions are going to save us when we get to the details, because then we're all speaking the same language. When you use the word student and I use the word student, we're really talking about the same thing. Now, I know it's a conceptual data model, and I have this acronym BTM for business terms model. Why is that? Well, I started writing a book called The Rosedata Stone, and it is a book on why the conceptual data model is so important for the business. And while I was writing the book, I was explaining why, and I was using the phrase conceptual data model and CDM, and I very quickly realized I can't call it a CDM conceptual because no one's going to take it seriously. The model really is for the business. So I gave it some thought, and I realized, you know, it is all about business terms, and it's for the business. I've been working on so many projects over the last 5 years where my main contact is data governance, and they're looking to come up with a common vocabulary. They have a glossary, but they may not know exactly how the terms relate. And that's where this model really shines. That's really what it's really good for. It's so important what we call things. You see that over the years. Those of you who've been in the industry for a while probably remember RAD, Rapid Application Development. That doesn't sound as cool as Agile, right? Agile just sounds better. We've always had operations research and statisticians. They don't sound as cool as data scientists, even though a data scientist does a little more, of course, but it's based in statistics, a lot of their work. And there's other terms like that too we can go through, like the data mesh and so on. They all just sound really good, and they work because of that. Conceptual, you sometimes think of optional. Well, if we have time, we'll do the conceptual, but we really got to get these tables implemented. Where the business terms model sounds like something we can't do without. And also, often we say the word conceptual in the same sentence with logical and physical, and it's so much more. Sometimes we just build the business terms model, nothing else. That is our one deliverable. So it's not, doesn't always have to be a step to the logical. Now, the conceptual comes with challenges. The business terms model, call it what your audience likes to call it. I mean, I prefer the business terms model, comes up with challenges, and there are three very big ones. One has to do with connections, where once you build the business terms model, how does it relate to other models? Two examples of very important connections are, let's say you build a business terms model for your organization. So it's an enterprise business terms model, an enterprise conceptual. and then you want to connect it to a project conceptual, a project business terms model. How do you map that? How do you maintain that? So one very important connection is from program to project, from enterprise to project. The second important connection is once you already have your business terms model done, how do you map that to logical, which then gets mapped to physical? So those two connections from enterprise to project, from business terms to logical, very important to create and then maintain. And that's a real challenge a lot of organizations have. It's actually one of the reasons I'm really excited to hear what Jamie is going to say next, because ER Studio has support for both of these kinds of connections. I'd like to see that. The definitions are also very important. It's easy to come up with some generic definition, like a customer is somebody who buys our product. Much more important to come up with a detailed, precise definition that adds a lot of value to the model. I really worked with a manufacturing company, for example, and we were finding the term material, very important term for manufacturing, and it was the material area, and the definition was almost 2 pages long. Can you imagine that, writing a 2-page definition? Well, the first paragraph talked about what the term is, and then the other page and a half or so talked about what the term was not. And you'll find when you start writing some really good definitions, it's even more important to explain what the term is not. And keeping these models up to date, really, really important. It's going to tie to connections as well, because if we have lineage in place between the models, it's easier to keep them up to date. Now, why does data strategy need the business terms model? Most important reason is to have a common business vocabulary. It was really interesting. About 3 or 4 weeks ago, I had a chance to talk at the Uncork conference. Uncork is a very big no-code company, and I got to share some of the keynote and talk about why data modeling is so important to over 500 executives in the audience. And then I got to listen to their talks as well. And there were some very senior people talking about some of the issues they're facing. And one guy from a very well-known financial company kept stressing that he sees one of the biggest issues not having a shared vocabulary, common business vocabulary. That's what the business terms model gives us. And also, if you do agile, and most organizations do some agile today, one of the challenges I have faced is the silo challenge, where agile is very much heads down, getting something done quickly, iteratively, and often at the sacrifice of the big picture, seeing how all the different projects connect. And what the business terms model lets us do is show the big picture. So it becomes a roadmap. We can say, okay, for the next 4 sprints, we're going to focus on this part of the model, and then we're going to focus on that part of the model. And it becomes a very powerful map for the entire program. Also, you can use the business terms model to show how all your existing pieces fit together. I started working with another organization actually this week, and what we're doing is we're looking at a lot of pieces of their organization applications, and we're taking a business terms model and we're going to use different colors to show how each piece fits in with this larger model. And also, if you think about that game Telephone, where we whisper requirements around the room, isn't it great to get off to a good start with the business terms model? Because then, at least a third of the way around the room, everyone's talking about the same thing. All the business people and business analysts, and even the data architects and data modelers are all communicating using this model. And really, if you think about what we do, and if you attended our last IDERA webinar where we talked about modeling from MongoDB and JSON, I introduced the idea of align, refine, design. And really, what the business terms model does is it gives us that align piece, making sure we're on the same page, making sure we're speaking the same language. And I mentioned I teach data modeling. I've been teaching for many years. This cover is actually our 10th edition of the class, which just got released this past summer. And I really stress in the class the ideas of align, refine, design, where align is all about coming up with your vocabulary, just making sure you and I are speaking the same language. Refine is about focusing on the requirements. Once you and I know what a customer is, for example, what do you want to know about the customer? What are your requirements? And the very important property of the logical, the refine step, is it's independent of technology. So it's a simple view, really. It may not look simple on some logicals, but it's simple in that it has nothing to do with a particular database or tool. And design actually makes it real. It takes our logical for requirements and translates it into technical requirements for a particular set of tools. So I always remember this saying, align, refine, design. It's easy to remember because it even rhymes. Aligns about your vocabulary, refines about your requirements, and design is about your schema, your instantiation. And if you think about the different kinds of models out there, we have 3 levels of modeling: align, refine, design. We have different kinds of models: relational, dimensional, and NoSQL. And in our last webinar with IDERA on MongoDB and JSON, we went a little more into detail into these, especially the NoSQL section. But just to give you a taste of the business terms model, let's look at an example of each of these: the relational, the dimensional, the NoSQL for business terms. So here is a relational business terms model. These entities represent business terms. And because it's relational, and relational focuses on rules, these relationships capture the rules. Each customer may own many accounts. Each account must be owned by one customer, not 2, not 0, but 1 and only 1. In addition to the model, of course, we also will have definitions behind these terms. And then a dimensional business terms model focuses on navigation. The entity in the middle is the process we're measuring. Here, we're measuring the fee generation process. And then all the entities around it show different levels of detail. So we can look at fee generation by branch, customer category, month, and account type. And then look at that same process, not just at a particular branch level, like the branch in New York, but for the whole Northeast region or the Eastern District. And so we're looking at a process, at how well it's doing at different levels of granularity. The dimensional is all about analytics. And then the NoSQL is all about discovery. This is an example of a NoSQL business terms model that we talked a little bit more about in our last webinar when we were talking about JSON and MongoDB, but NoSQL is very much focused on the query. And so here, well, if you look at the differences really quick, if you look at the relational, the lines represent the business rules. Dimensional, lines represent navigation paths. And in a NoSQL, the lines represent dependencies amongst the queries, the sequence of queries or the dependencies among queries. And so the top 5 takeaways from this talk: one is that the models are precise, and therefore they are amazing communication tools. There's only one way to read anything on the model, and that gives the model its power. Remember the business terms model. It gives us that common business vocabulary scoped for a particular initiative and tailored for a particular audience. If you think about conceptual, logical, physical, doesn't it sound better to say align, refine, design? Makes a good t-shirt or a hat too. I have to remember that. Align, refine, design. And the business terms model is really that align piece. 3 challenges with the business terms model. One is connections. How do you connect the enterprise to the project, or the project business terms model to the project logical and physical? Definitions, get really good definitions, and have a process in place for keeping the models up to date. In terms of connections, remember these: enterprise to project, business terms to logical. Really, really important. Make sure your tool supports that. And with that as a segue, I'm going to turn it over back to Crystal.
Thank you, Steve. Now we're going to go over to Jamie for a quick overview of the new features of ER Studio. Jamie, over to you.
Good stuff. Thanks, Crystal. Which of those guys on that bike was ET, Steve? Was it the one on the front or the back?
Do you know that I actually touched that ET doll and they got angry at me because apparently it's a museum piece. They actually stored that in a museum. They didn't want me to tap its head or anything. Yeah, really something. I'll turn it over to you. Thanks, Jamie.
Right, so I'm going to try and share my screen. It's can you guys see my screen at all?
Yes, we can. Except, can you maximize the window because it's still on my on the last slide?
What are you seeing? Are you seeing PowerPoint with enterprise model or a picture of you and me?
I see a picture of the enterprise model, and so that works fine. Yep, that looks good. It actually does look good. Yeah, it looks perfect.
So I was loving what you were saying about sort of communication and precision of language. And I think in real life we use sort of glossaries and dictionaries and thesauruses and phrase books, which are absolutely vital if we want to communicate. Whenever I go on foreign holidays to places like the US, I always take a phrase book with me to allow me to convert my language and not get confused. So some good stuff there. So I think there's two areas that are of interest to me. I want to show in the tool. One is the sort of enterprise data model and having an enterprise scale conceptual model to sort of standardize the language across the organization. And the other one is when I'm starting a project, then starting with that business term model to get those high level requirements. So here on the diagram, we can see that there's kind of three independent models. So right down at the bottom, for each of my data assets, I'm going to create a model in ER Studio, hopefully. I've got the physical model there that is faithful to the technology. I've got my logical model, faithful to the information, and that's specific to the project. And then I've got all my standard stuff at the top. So I might have one single overarching business term model or enterprise conceptual model with the sort of small number of concepts that the organization really cares about. And then I'll drill down and create an enterprise logical model, again, with standardization of those concepts. Interestingly, I was thinking of projects that I worked on where we're trying to build an HR system, and we spent a lot of time and we wrote a lot of code, and we have real problems with shift patterns in this HR system until we realized that there's actually 7 different types of shifts that are very, very different. So maybe in the sort of conceptual model at the top, I'd have the notion of shifts. And then down in my enterprise logical, I then start to explore things like different subtypes of shift and show the different types. But this sort of model here is really useful. So these are the small number of things that the enterprise cares about. We've now got a lot more detail around them. We can see all those sort of super subtypes. That little symbol there is telling me that there's different types of company. And then I can see in terms of all of the projects. This is where that little travel phrase book comes in. So yes, in our country, we talk about customers, but over in sales database country, they talk about clients. Okay, great. But the tool is going to help me understand that. Just to show you that in the tool. So here's ER Studio Team Server. So I can browse through all my different data models. So here I've got a folder with my corporate or enterprise models. Here's my corporate conceptual model. I can open that up. Very simple model. So exactly what Steve was showing you with his business term model. We've got those high level concepts. These are all the real important concepts the company focuses on. Employees, employed to do jobs in departments, many to many, employee manages different customers, great. Now I can drill down through that model like I was showing you in the PowerPoint. So there's my enterprise standard concept of employee. Now here it tells me that, oh, there's actually different types of employee here. I've got contractors, full-time employees, and then employee itself. So I might say, oh, well, the general employee, all the contractors and full-time employees, let's go and look at that. And
I'm sorry to interrupt. We have a couple of people who say that they can't see your screen. They can see you and Steve, but not your screen. I don't see it either. So maybe if we could refresh,
Yeah,
possibly?
let me stop sharing and start sharing again. Let me stop sharing. So you should just be able to see.
Sorry about that, everyone. A technical. There we go. All right, we got it.
We got it back. Brilliant.
Thank you.
Okay. So let me just sort of go back. So we started off, we looked at there's our enterprise conceptual model employee, and then we can drill down and see that there are different types of employee in our enterprise logical model. Getting into more detail, we go to our standard definition of an enterprise employee, and then we've got this model expands out again. So I can see here, coming down from the top, my enterprise conceptual model, there's my enterprise logical employee, and then these are all the different projects that contains employee information. And these guys down here over in publications land are using the word staff. So that's our sort of translation side of things. So that's the sort of a way you can use an enterprise conceptual model in ER Studio and then publish it through this sort of nice web-based team server app and let people browse through it. The main thing is that we're standardizing our definitions here. We've got our high-level catalog. Again, I've got a more detailed version. Our standard employee at the logical model will have standard attributes of, and those standardized attributes will have properties for them. So the data type, definitions of them, will have perhaps standard keying structures. This is how we identify an employee in this organization as our primary key. We might have alternate keys. These are other ways you can identify an employee. So there's our enterprise data model. Now, one thing I think it's worth just mentioning. So Steve used the term business term model. Now that might potentially confuse a few folk in that we also have another tribe of people in the organization, the data governance tribe. Now they also have a similar mission to us as data architects, and they want to standardize the information of the organization, and they create these things called business glossaries, and in them they have business terms. Semantically, there's usually a lot of similarity between our data models, probably the enterprise conceptual, enterprise logical, and then they have this big old list of business terms. If we're very, very lucky, that yes, they've standardized those terms and put some useful policies and rules and definitions of them. If we're very lucky, they might have these ontological relationships to see that sort of company has different types. A company could be a vendor or a client. A client has an attribute of a credit rating score. Usually it's just a sort of a flat list of terms. So one of the challenges that we have as data architects in our tool is being able to reconcile these two different models. So our business term model over here, owned by the data stewards, they'll be maintaining this. We as the data architects, we've probably got a little bit more precision around our model. We're creating nice, rigorous, robust models using entity relation diagrams, much cleaner type of model. So we'll maintain that over here. And then in ER Studio, we can build relationships between them, which is really useful. So I can navigate from any point. So from the bottom, I've got a database, a sales database. It's got a table called CLNT and a column called C_RTNG. What is it? I haven't got a clue. But ER Studio will tell me. It'll say, here, here's a logical model, which gives you a nice structured view of it. Or you can hop across to your business term model with their definition and all the policies and rules around credit rating score. Great. A very useful model. Now, the other scenario, and I'll do this pretty quickly, is, so Steve was talking about the design journey. So somebody's come along and say, hey, I want you to design me a data asset. So you'll start that conversation. Okay, so what do you want to put in it? Now, there's various ways of doing that. So in ER Studio Data Architect, I could start off by just drawing the entities here, drawing my many-to-many relationships, and great, there's my conceptual model. And we all agree, great, that's what I want in my database, please, Steve. Off we go. And then we can elaborate this. And we're actually drawing it as a logical data model in ER Studio. And then we can kind of swap these relationships and change them for more precision, reconcile them with an associative entity, etc. Add our attributes in, add our keys in, and sort of continue the journey. There's some other features in ER Studio that might be quite useful. So as well as being able to draw entities and attributes in these entity relation diagrams, we can also create these big green boxes here, which are called business data objects. And you can use these in in all sorts of different ways to represent different things. So a useful thing is to use these to represent that initial conceptual model. So I could create something like this. So yep, so I want Steve to build me a database that's going to contain employees, departments, agencies, training courses, and skills. Super, there you go. And then he'll come along and he'll start to drop into each of those business data objects, the entities that will give all the detail. And the tool will actually allow you to sort of roll up and roll down these different business data objects to give you more detail. So the difference between those two approaches, one, I can start off just creating logical entities as my concepts, or my business terms, and then elaborate them. Or if I want to sort of persist that business term model, then I can use a different type of object, which these business data objects, and then elaborate them with the formal entities underneath. Great, that's all I wanted to talk about today. So questions? Do we have any questions?
Great, Jamie. Yeah, we have a question. Maria asked, she said that she sees that this is open in Calibra. Do you have to have Calibra to do a CDM?
Well, that's a great question. So yeah, now the model I was showing you here earlier on. So I think this is the challenge for us as a tooling vendor and you as organizations. Again, you're going to have different groups of people owning different parts of this. You're going to have your data stewards owning the business glossary and the business term model. They might be completely isolated from the IT team. They might be using their own products. So Calibra is a great tool to be able to produce and manage a business glossary. Calibra will then allow you to create a data catalog where you go through all of your data sources down here, your data assets, sales database. Calibra will reverse engineer it. There's my model of that database, CLNT and C_RTNG. And then in Calibra, someone will then go and find out, well, what is this table? Oh, that's customer. So they'll map it to customer. Over in ER Studio, we've got a similar sort of model over here. So what we can do with ER Studio is now synchronize with Calibra. We can also synchronize with, we're about to be able to synchronize with a bunch of other data governance tools as well. So we can synchronize the business glossary across the two tools. We can even, a lot of our customers have created a beautiful enterprise conceptual model or an enterprise logical model already. They've been using it for 10 years. So what we can do is we can actually harvest terms from either the conceptual or the enterprise logical model, harvest all those terms and the relationships between them, because semantically here there's relationships, create a first business glossary and push that over into Calibra. Then the next job is obviously sort of going through mapping those terms to all of our data models, and you can do that inside Data Architect. Those Calibra terms are available to attach to stuff and then publish the models to Calibra. So if you don't have Calibra, you can do all this in Team Server. We don't have all the knobs and whistles and features that Calibra does and workflows, but to create your first cut model, a good business glossary, good data catalog, you can do that in ER Studio very quickly and easily. And then as you take a tool like Calibra on, we can push all this across to Calibra, continue the journey in Calibra.
That's really interesting. I'm working with a client now who's doing something exactly like what you're describing. They're using Calibra. It's their main tool. They have a lot of their lineage in there, and they have their business terms. But what they like about the modeling tool is that it creates this useful diagram. And so they store their diagram within Calibra. They do it in the modeling tool. I'm assuming what they're doing behind the scenes is what Jamie's describing with all the mapping down there, but they like the idea of a very simple visual. Calibra lacks a really good visual modeling tool. Okay.
I think that the next challenge for that sort of world is where stuff changes. So definitions of things change, the classification of things change. So let's pretend that our data stewards have got a new definition of what is a credit rating score. They've also decided, well, this is quite sensitive information. We should make sure everybody knows about that, and we'll put a PII flag on it. So the challenge then is, us as data architects, we've got our models here. So maybe we do have an enterprise logical model. We're using that to sort of seed designs of new projects. we want to make sure that our definitions are the same as what the data stewards are doing. So something we're building at the moment, it's sort of a compare merge tool. It says, for this logical model here, compare the model to all these business terms that they map to that might have come from Calibra, and tell us what's different and allow us to update one side from the other.
Interesting.
That was a long answer to a short question.
Well, we have another question, and I believe it's on the next slide with the green boxes. Sean asked, how are the green boxes connected?
So yeah, these green boxes, how are they connected to my blue and gray boxes? Yeah, so the idea is in Calibra, someone's going to come along and say, okay, there's a SQL Server database here, there it is, or reversed engineered it, table called EMP. In Calibra, they can map that to the business term. So how do they work out, well, what is EMP? They've got to go and read some documentation, talk to somebody. So somebody they might want to talk to is the guy or gal that designed it in the first place, the data architects in our studio. So what we're trying to do is sort of bring the business glossary closer to the data architects and get them to do the work. So if I hit add term here, I can go and select the glossary, human resources. Hopefully you can all see this on your screen. So it's then EMP, it knows the logical name for that is employee. So it's going to search for any terms with employee in the name. Oh, there's one, employee. And then I can relate it. So here in Data Architects, I can relate the business term to the entity or the attributes. And then when I publish this model across to Calibra, it goes with the mapping to the business term. So I'm publishing all of this to Calibra along with these green lines. Did that answer the question?
I think so. We have another question by Mark, and he wants to know if you can create an entity and tag it as a conceptual only.
Create an entity and pad it out with conceptual only. So there's different views in the model. So let me go back to this fella here. So once we've developed this, we've got our attributes and our keys and stuff. There's various different ways you can display it. I'm not sure if this is answering the question. So I can say, just give me an entity view. I can say on here, so I've taken away all the attributes to show the definition of it. So that's another way of sort of displaying this to make it more palatable and consumable by business users. Not sure if that answers the question.
Jamie, you know how like when you go from logical to physical, you can hide some of the entities and say logical only? Can you do the same thing, go from conceptual to logical? Interesting.
Yeah, don't know about that. That's
yeah. I don't know if that's where that question was going, but it led to this question. It's kind of an interesting way to look at it, where you can say, okay, this business data object is only conceptual only, not logical.
Yeah, I mean, you can create different submodels in the tool that represent different parts of the model. So you could sort of chunk it and have group things together. They're all different sort of views on the same model.
Yeah, interesting.
All right, our next question is from Mark, and he asked, if I draw a many-to-many between two entities in a CDM and the same entities show up in the logical model, will the many-to-many relationships still show up in the logical model?
So we've got nothing clever in the tool to handle that right now. Now, if you took a logical data model with many-to-manys in it and created a physical, it would automatically create you an associative entity and reconcile that. But we don't do anything when you're converting from conceptual to logical. And in fact, really there is no conversion between conceptual to logical when I'm in a project type view. It's really the same model. So these business data objects are just sort of groups of entities, and you sort of elaborate them. We don't do anything fancy there. I'm sure you could do some sort of macro that would help you with that. And if you've got any ideas on what we might want to do, then we can talk and maybe build something into the tool.
It's actually a good idea when you're first starting or logical to have your many-to-manys present, because your first cut logical is probably going to look a little bit like your conceptual, except maybe there's lots of attributes. And what you do is you start normalizing that, and those many-to-manys get resolved when you hit second normal form. So it's a really good idea to have many-to-manys, at least initially in your logical.
All right, great. And then Greg asked, what are some of the reasons why the DG definitions should differ from their CDM counterparts?
I actually have experience in that one. Jamie, I don't know if you mind if I could share. I worked with a large insurance company that had that situation. And the main reason was it had to do with the two factors why we create the business terms model: initiative and audience. So the data governance glossary is scoped by a group of people who have broad business experience, and they're defining it in terms of how the business works. The conceptual data model has maybe the same terms, but it might be scoped differently. We might learn that the way they built this conceptual is by studying how a vendor package works, or they built the conceptual by focusing only in the sales area and not looking at the broader picture. I once did this project where I had to reconcile a data governance glossary from an enterprise conceptual model, from a data warehouse conceptual, and it was almost like reconciling 3 different companies because they all had different scopes and they were for different audiences. So those are the 2 main reasons usually. It's audience and scope.
Thanks, Steve. The next question is from Ash, who asks, do you have any thoughts on the best way to create a BTM conceptual data model from canonical message data model?
Yeah. So actually, this slide is great to look at for that. So if you look at the canonical model, and actually even our talk last time when we were looking at JSON, so often the canonical models are represented in a JSON schema somewhere, and they show how you would standardize on exchanging data between systems. So what we wind up doing is, and you could see here on Jamie's slide that there's no directions to these arrows, meaning that you can go up or you can go down. So in the case you're describing, you actually go up. You start with the physical, and we're going to take these JSON files and you would reverse engineer them into ER Studio and then work your way up to the conceptual. That's how the tool would allow you to do that. That's the easy part. The hard part is going to be to reconcile, and it goes back to the earlier questions, to reconcile these different audiences and different initiatives to kind of sew them together at a high level. And that's where all the time comes in.
Yeah, and ER Studio's got some really cool new features that came in 19.3 around JSON and messaging, and that whole sort of API world and JSON world we're going to be doing more in. So this is our sort of ideal model where we've got a sort of central enterprise logical model, which might form the canonical model for everything. So we've got one company over in Sweden, they make furniture. So they're reverse engineering all their application databases, creating logical models, polishing up, creating a central logical model, then coming down to design their JSON messages in ER Studio. So we now support these hierarchical structures of Mongo, JSON, and BigQuery. We've got another company in oil and gas. There's an oil and gas model, which is a set of JSON messages, and they want to do exactly that. It's like we're trying to figure out all these different JSON messages. So you can reverse engineer a JSON message from that hierarchical structure, create you a nice logical relational model, and then you can mush them all together with compare merge and create one overarching logical data model. And then from that, you might want to then just boil out a nice simple conceptual model that summarizes the whole lot on top. So some great use cases we can really help with there.
Thank you, Jamie. The next question is from Abdul, who asks, how is the BTM and common business vocabulary differ from taxonomy, ontology, knowledge graphs, etc.? Is there a symbolic relationship between these various vocabulary term management capabilities?
Wow, that's awesome. Yeah, these are awesome. So yeah, so what happens is, so there's a short answer and a long answer. The short answer is that they're really the same. There are different symbols we're using to capture different kinds of relationships. So in the models you've seen in this presentation, the lines could either represent business rules or navigation paths or query sequence or dependencies, depending on whether it's relational, dimensional, or NoSQL. In a typical taxonomy, the lines really represent the concept of a subtype or showing examples of something. And and also in a graph, the lines represent patterns or similar to dimensional, how to navigate from one place to another place. So part A to the answer is there's lots of different notations we can use to get the point across, to be able to capture the common language. We could build a taxonomy using traditional data modeling symbols like subtyping, or we can build a taxonomy using other kinds of symbols, even JSON. You can build a graph using, one of the books we published is called Graph Data Modeling, and they recommend a concept model and then have other kinds of models underneath that. So part A to the answer has to do with notation. And in that case, the answers are the same. It's just using a different notation to explain the rules. Part B to the answer is a lot of times when you're modeling a taxonomy or a graph, you're focusing more on instances than you are on metadata, where here in our slides, we're talking about customer and product and account, where a taxonomy or graph, you're often focusing more on the instance data. So you want to know, for example, on a graph that Steve has some kind of relationship to the movie E.T. How do you know that? Well, he bought a bagel at the store and the bagel store hired this museum. And so it's more about instance modeling than it is about metadata modeling. So just to summarize, part A to the answer is many different ways to communicate the conceptual, the business terms model, its notation. Part B to the answer is sometimes a distinction is instance versus structure, data versus metadata. I don't know, Jamie, if you want to add anything to that.
Yeah, this is quite an exciting area. And I think to your point, Steve, in literal terms, then in this model here, we can see our business terms in our data governance world can be arranged into an ontology that includes taxonomies. So the is type of relationship here allows me to specify that company has types of vendor or customer. I've got different types of customer. I might have a domestic customer or a corporate customer. So there's your taxonomy of a company or party. So you could hold an ontology within your business glossary. Your logical data models are effectively an ontology. To Steve's second point, so the term knowledge graphs seems to come up more and more around associated with analytics. There are some great tools out there. There's a tool called Pool Party we've been talking to, where using AI, it'll look at all your data and then come back and give you a knowledge graph of all of your data. Well, super, but there should be some sort of similarities between the knowledge graph that you harvest from the data and the knowledge graph that your architects and data stewards are building over here. So if you think about this structure, so I've got all my application databases, MongoDB, JSON messages, this is all the metadata, but in terms of the data, there's then like a whole bunch of extra stuff underneath. So your sort of knowledge graph from your analytics tool will give you all of the metadata at the top and then go down into Steve and Jamie and Crystal as the actual data. So what we're trying to do is to sort of close the loop and say, well, we've got our version of the ontology up here, either in the business glossary and or the logical data model. Can we harvest any ontology from what the analytics tools have created and feed into this and give us an overarching ubiquitous model?
Thanks, Jamie. The next question is there any interface available to store the data model diagrams in Microsoft SharePoint?
Not at the moment, no. You can, there's lots of features in there to sort of create an image from a diagram. You can create reports. We use Team Server to publish all of our models and allow people to browse them. Because the models are so complex, we want people to have that sort of interactive experience where I can sort of drill down through the model and find out sort of where is this data. Trying to recreate that all in SharePoint becomes quite tricky. We've been asked for it a few times, but it's something we probably wouldn't do or want to do. Things get a bit gnarly.
It's interesting. Yeah, I wonder if this relates to where I mentioned I talked at the Uncork conference a few weeks ago. They're a no-code company, and one of the things I did is I extracted a JSON file out of ER Studio of the model, and I sent that to Uncork, who was able to actually develop an application based on the model. It was actually a great connection from model to application. And I wonder if some kind of similar interface is possible to other tools, although I'm not familiar how SharePoint handles JSON, but it's kind of an interesting question.
Thank you. And then someone wanted to clarify if one of you had said that you can reverse engineer a JSON file.
Yes, 19.3, Diane. Give us a shout and we can give you a demo. There's some really cool features that came in. So we really want to go to town on this. So the whole idea is from a standard logical model, I can generate a JSON structure as a physical model in hierarchical form. There's lots of features in there to add in all the JSON schema stuff and output a JSON schema file or JSON instance sample file. Likewise, we can reverse engineer a JSON schema or JSON instance file like this, and boom, hey presto, it creates a logical model from it. So it's quite a cool use case where you can reverse engineer some JSON. There's your logical, take the logical through to third normal form, so add in some keys, and then generate a SQL model. So I can now, if I want to load my JSON into a nice SQL database, I don't have to stuff it all into one column of type JSON. I can put it as a properly normalized model that I can then run my BI tools on. Give us a shout, we can tell you all about it and give you a demo.
Okay, we have time for probably one last question, and that is from Ash, who asked, I'm wondering at this point if ER Studio can catch basic design flaws like circular reference relating to entities and making it dependent on each other at the same time.
Yeah. I actually, Jamie, if you don't mind, I actually have experience in this one with ER Studio. So ER Studio could actually capture the circular relationships when the relationship lines are identifying. So for example, if you have 3 entities and they have a sequence of identifying relationships to each other, ER Studio catches that very well. It actually, the way it catches it, it just gives you a beep. It doesn't send you a message saying, hey, silly, you shouldn't be doing this. It just says that this is something that you can't do in data modeling notation. However, if the relationships are non-identifying yet required, ER Studio will allow that, even though technically it could be a circular relationship. So there's 2 kinds of circular relationships, those that are identifying, and ER Studio catches those, and those that are non-identifying but required, and ER Studio allows those. And I think part of that is there could be valid rules why a non-identifying required relationship is allowed. So it lets you create that, and hopefully as the modeling progresses, you can go through and adjust it.
Great, thanks so much, Steve and Jamie. I would like to invite you to head over to IDERA.com where you can download a free trial of ER Studio, which was highlighted for us today. Thank you all so much for joining us, and we hope to see you back at a future IDERA online event.